Okay, before we look into the other two solution or possible solution, I want to help you recall regarding the rules of a circle. Okay, so you can draw this or online on the other side of the screen, or I can do it. Okay, so I'm drawing a circle now. So this is a circle that I've drawn, and over here by observation, I'm going to call point O, which is the center of our circle. Is it center? Yep, spot on. Then from here, I pick a arbitrary point, and this point is point A, right? And then from point A, I'm going to go through point O, center of the circle, and I'm going to cross the other side of the circumference of the circle, and this is our point B. Okay, and I'm going to arbitrarily pick a point. Okay, and I'm going to pick a point somewhere around here, and I'm going to call it my point C. Now, if I were to join a line from point A to point C, right, and then from point C to point B, right, and if you were to use a protractor to measure it online, right, this is spot on held at 90 degrees, very accurately. Okay. And then from here, I'm going to draw point C. So that's one rule of the circle, right? So you construct, you pick a point A, going to point 0, meet a point B at the side of circumference. And at point C, you join point A to C, C to B is 90 degrees. Okay, that's rule 1 of the circle. And then now if I take at point C, going to point O, right? And if I were to measure this angle over here, this angle will be, I would call it an alpha angle. And we are aware that this angle over here will be 2 alpha. Okay. So if I were to, I'm taking my protractor to measure it now. I'm clocking at about 35 degrees. And if I measure the other angle, it's clocking at 70 degrees. And why is that? Okay, because this angle over here is also alpha due to the fact that these two distances are its radius. And this angle over here is equal to 180 minus 2 alpha. So that's where this angle here is 2 alpha. Okay. So this is what we call the rules of the circle. Okay. So I'm going to copy this circle over here. Okay. And we're going to construct the next 2 points. Okay. And I'm just going to paste. Okay. And I'm going to string it. So we are still dealing with the same problem. Okay, we found one stress y value. We have to find the other two. Okay, right. So we are still going to construct Mohr circle, right? And I'm going to look at the negative side. We don't need to draw the positive side. Okay. So this is minus 160, 140, 120, 100, 80, 60, 40, 20, 0, 20, 40. Okay, so this is our normal stress. 2, 4, 6, 8, 10, 2, 4, 6. Okay. And then our y-axis. So normal, our shearing stress. Clockwise, anti-clockwise, minus 20, 40, 60, 80, 20, 40, 60, 80. Okay, and then I'm going to draw our boundaries, right? Our 75 boundary. Hundred and 50 of 75 boundary. 150. So this is our box. So it cannot go beyond the red shaded region. The material will yield. And then we have our minus 70. And then we have our 40. Then we have our negative 40. And we are very sure that over here, this is our point X. Okay. So we know that the maximum shear is 75. The circle cannot be more than 75. Okay. So the points that we know is we know that this is our point Z, right? And we also know that the circle has to be within the red box that we've drawn. I only drawn the negative part only. So the first thing we're going to do is we know that all the three circles or two of the circles, right, has to touch this point. And this is our stress A, right? That's our principal stress. It has to be at that point at minus 150. It cannot be greater than that. Okay. So now I'm going to draw stress mean, right, or stress A to point X. Okay. Now, point A is not my average stress. Yeah. I want you to watch. Point A is not our average stress. Okay. Right. So I'm going to apply, or we are going to apply the rules of the circle that I have down here now. We're going to apply the rules of the circle, right? So I'm going to, I cannot rotate or whatsoever on this, okay? So I'm going to apply the rules of the circle, and point X is in fact our point C, right? And we know that point C, right, to find the diameter or the orientation of or the distance of the diameter, you just need to construct 90 degrees at point X. Okay, so let me show you what I mean by that. Construct 90 degrees. So I copy this, right, and I paste. And then I just need to rotate this by 90 degrees, right? And we know that this is our 90 degrees line. We know that this is 90 degrees. Okay. And over here, this is the other principal stress. Okay. And I'm going to call it stress C. Okay, we go for. So we need to find stress C to find the diameter of the circle, right? And then we have to determine what is our stress average between stress A and stress C. Okay, so I'm going to like string this down. Now, if anyone is having question on the chat, because I cannot see the chat screen, someone just tell me there's a question, okay, if anyone is confused. Right. So now we're going to find this line over here, this angle over, I'll use a different color. This angle over here, which is our alpha. And the angle alpha over here, due to similar triangles, is also alpha in this angle over here. Okay. Now, okay, it might be confusing if I call it alpha, because some of you see alpha like the previous example. So I'm going to call this our beta angle. Okay, so this is our beta angle. Okay, so to find tangent beta, is equal to what? Is equal to 40 divided by 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Why 40? Is because the distance from here to here, right? This distance over here is hold on. This distance from here to here is 40. And the distance from here to here, I hope oh sorry, it's not 100. It's not 10, 20, 30, 10, 20, 30, 40, 50, 60, 70, 80 is 80. I do apologize. Right. So this is 80. Right. Yep, this is 80. So beta angle is equal to 40 divided by 80 inverse tangent is 26.565 degrees. So we know that stress C is equal to minus 70, right? And then minus 40, minus 40. Oh, sorry, plus is going towards the right hand side. 40 tangent 26.565. Okay. So what we are trying to find is this distance over here. I'm going to draw in red. Okay, this distance and this distance, right, correspond to this formula over here. They correspond to this formula over here. Okay, so this will be equal to tangent 26.46 times by 40 minus 70 plus by that is equal to, oh wait, tangent 26.565 times 40 is equal to 20. So minus 70 plus by 20 is equal to minus 50 megapascal. Okay. So from here, we can determine our stress average line, which is equal to minus 50 plus by minus 150 divided by 2. So this is equal to minus 100 megapascal. Okay. So we know that I'm going to draw a green line. This corresponds to our stress average. This is our point O, right? And then from point X, I go to point O, right? It's our point Y. So this is our point Y.